Welcome everybody once again. As it was already mentioned, my name is Paweł Tomasik, and today I'm going to talk about cost savings in software development. So right now, together with that COVID age, a lot of companies was forced to tighten their belts even harder than usual. And that may become a source of frustration for lots of engineers. Of course, I will not provide any magic spells that would solve that problem completely, but maybe try to help a little to reduce the amount of that frustration to maybe some acceptable level. In my opinion, the first step to do that maybe is to set the right perspective over our roles as engineers. One may say that the role of engineer is to create a code, to create the software, and that's true, of course, but only to some extent. Because as long as we are working in a commercial company, the brutal reality is that the main goal for every software project is to generate revenue. And revenue is not generated because we just written a code, but because someone is willing to pay for that. The more accurate statement would be that our goal is to run a software business, once the code creation is just a way to achieve that goal, not the goal itself. Of course, if somebody wants to be a pure engineer, focus on code creation and strengthening its hard skills, that's completely fair. Actually, hard skills for developer are really crucial. So they are as crucial as big muscles for a heavyweight boxer. You won't achieve much without them, but it's not enough to win every fight. So my point is that if somebody has ambition to be really valuable engineer, he needs to look beyond the code he creates. Look usually for something which is often called company success. It's one of my favorite corporate words, a company success. It can be translated to different things, but in my opinion, the most important translation is the ability to create a competitive product. So the product that better than others can do. And for me, the definition of that kind of product is the product with the right set, right proportions between feature set, the quality, and the cost. And those proportions may be different for different natures of the software we are creating. So that shall be completely different stuff when we are creating some internal tool, banking application, or maybe jet engine driver. So identifying that proportions can be now built on the top of understanding our customer needs. So what would make our customer happy? Let me give an example right now. So recently I went to the shop to buy a bike. So I'm not a professional, but I cycle pretty often. So I wanted to buy some reliable bike for a reasonable amount of money. However, I did not expect the high-end quality or feature set. Just wanted to make best usage of the amount of money I wanted to invest. And in software industry, the quality tends to increase the cost usually exponentially. So it means if we want to reduce the number of defects that are finally reaching our customers, we need to apply some more strict quality procedures that eventually slows us down. And the symmetric situation is with the features we want to add to our product. So here also this characteristic is non-linear. Actually, it is more or less linear as long as we are talking about single team development. But if we add more people, we need to pay for that overhead over our organization. The important thing for us is to find the right places on those charts that would be our targets. And that choice is pretty sensitive because even small pivoting on the horizontal axis has a significant impact on that cost. And the cost is, the crucial here because every company that decides to invest in software development, either by creating its own software department or by buying the software from third-party vendor, eventually expects to to accelerate its core business and to get even more revenue that they just invested in that software. That's pretty obvious. So only if we know our goals, we can start to talk about our engineering foundations, like the practices, like architecture, like coding style, like test practices, or even customer relations. So talking about the stuff detached from the nature of the product, from understanding customer needs in our particular case is extremely inaccurate. There is no architecture that is good all the time. You may select the method of working that is okay, even if you have 200 people involved. But if we are working with two Scrum teams, we may choose much more lightweight approach that would allow us to move much faster and to deliver much faster. And the same for test practices. So we may enforce some really strict quality procedures that will move us to almost, let's say, this virtual zero defects policy, but at the same time, it will make our deliverables extremely costly, and slow. So that's really important. So as kind of foundation. So if we know that foundations, we may start to apply, some practices in our teams. However, often it happens that whenever engineers come with some initiatives, some proposals to the business, they encounter immediate resistance, because now whenever we start to talk about changing a framework, adding some more test layer, we often hear that there are really great ideas, really great, and they shall be done next sprint. Next sprint is usually often the best suitable sprint for doing all kinds of that stuff. And right now we just need to focus on features and even more features and more features. So we are overwhelmed with features, and that usually means that we start to introduce technical debt. And this technical debt causes some unexpected problems caused by some missing test coverage, pure telemetry, and so on. And that usually boils down to some delays. And delays means that some commitments are not met. And if customer commitments are not met, business usually falls into the panic mode and start to push over features even harder. And that closes the loop of this vicious circle of frustration, poor quality, and delays. So what can we do? Of course, the work shall be done on both sides. I mean, technical stuff and the business side. But as it is technical conference, I will focus only on this left side. So I mean, what we as engineers can do to help. In my opinion, actually, the first and the more primary step we shall take is now to start to make the business trust you. Whatever the atmosphere you have, do you like your business authorities or not? That's always the foundation. So you need to make them trust you. Of course, you will never hear from any product owner that they entrust you. And they are really eager to express their trust, usually by controlling you every day. So that was actually for me always the hardest part whenever I join a new team and start to cooperate with new product owner and the position of technical leader, that to gain that trust. Until then, I felt like my hands are completely tied. So every decision is challenged. Somebody is constantly looking at the backlog, adding some questions. Why we are doing this thing, not doing that things. The technical authorities seems not to be actually the owners of the technical side of the project. So what to do? So fortunately, it usually does not require any special things. It shall be enough just to stop doing stupid things. Examples? The most common mistakes that are taken by engineers in terms of relations with the business are following, at least for me. So first of all, talking about some technical details of issues you encountered. So you encounter some issues, you are not able to deliver on time, so you are starting to talk about it, providing the details, what options did you take, what libraries did you check, and so on and so on. And maybe some people think that this gives an impression that you were really involved in that problem. However, it's not exactly like that. I mean, technical staff is meant to and actually paid for solving technical problems. And the business authorities are non-technical guys, so we are going to them to assist with you. The impression you are giving is that you are actually not self-reliant as technical authority and have poor control over your development. So what to do instead? In my opinion, what we shall do as engineers is to really evaluate different options to solve the problem, but not from technical perspective only, but from the product perspective as well, and provide some options to be picked by product owner, but from the domain of business. For example, maybe there are some requirements that we can remove. Maybe that would be acceptable and we will still be able to deliver on time. Maybe we can ask some other team to change something on their API so our development would be easier. Options like that. Then it will prove that you understand the product we are working on, not only the code you are writing. And that's usually a game changer in the relations between technical staff and the business. And the second mistake is now talking about needs for refactoring or reduction of technical debt. Of course, that's important. And of course, often it happens that business does not understand how important is that. However, whenever you talk about things like that, the message that you are providing seems more like that. So you are asking business to pay once more for the things that they already purchased. And as a bonus, they will receive a couple of defects because refactoring usually means adding some more defects into the code. So what kind of reaction do you expect? So what to do instead? In my opinion, we shall not to talk about it at all. Actually, code maintenance or product maintenance from technical side is no internal thing for the team. And they shall be responsible to split the time within the sprint in a reasonable way for the feature task and the code maintenance task. And by reasonable, I mean in the way that after every sprint, there will be some visible progress to be presented. Why visible is so important? Because once the program progress is visible, usually there are no uncomfortable questions like, what have you been doing for the previous 2 weeks? And sometimes it happens that after this kind of question, there is an answer. Yeah, that's it. We were just refactoring our code, so some future development would be easier, and so on, so on. And at this point, you are just pressing this red hot button of anger and put your eye of Sauron onto your backlog, so you may be 100% sure that within next sprint you will do nothing related to the code maintenance. And finally, the third mistake is talking about some unfinished tasks and calling them even unfinished. So in my opinion, if something is unfinished, let's call it unfinished and make more realistic estimates for the next time. It's usually better to have hard time at the point of scope negotiation than being in a constant state of unmet commitments, because the impact on the trust is pretty straightforward. So if we are able to not to commit those kind of mistakes, that puts us to the pretty good starting point to start being treated seriously by the business authorities or our customers. And then we can start to organize our work in a way that is really most efficient for us and start to reduce everyday work overhead by changing some principles we have. So even then, the topic of cost reduction in software development is not an easy one. It's always easier to talk about need of adding new test layers, adding new test quality procedures or whatever. That puts us usually to the pretty comfortable position when some future problems in production occurs. Talking about cost savings is now requires more courage, but as long as you are at any position of taking decisions, any leadership position, you need to handle that anyway. So let's move on. The application I'm going to use to demonstrate a couple of techniques is creating using a hexagonal architecture approach. This term is probably familiar to you, but I will just provide a few words of explanation just as a reference. So within that approach, we try to split our business logic into classes called domain modules, here represented by this hexagon. And these domain modules interacts with external worlds using pods, which are technically interfaces. And implementation of those interfaces are called adapters. The core idea here is that our business logic shall be easily testable using pure unit tests where all dependencies can be easily replaced by regular substitution mechanism. So let's take more particular example. Let's imagine that we have application that has domain module that needs to talk to database. But we are not executing queries directly from our domain module, but using some DB adapter as a proxy. And this DB adapter takes now ownership over configuration, connection management, and so on. Everything that is difficult to stop. And if we need to talk to some external service using REST interface, again, we are not executing HTTP queries from our domain model, but using some peer service client as a proxy. And this adapter takes ownership over connection management, input validation, error handling, and so on. And finally, we can talk to some other domain module inside the single service, also using the same approach. So if you know that, I can present you right now how this application looks like. So this is the monitoring application for the Wild City Police Department. And what we have here is just the the map of our city, split it into a couple of zones, and we here at the bottom we have the schedules of patrol. So which officer is patrolling which area and when. And here we have some dates, so we can select different dates and monitor the schedules of patrol for those days. As simple as it could be. And recently we added a new feature for that called hot zone reporting. So the one zone is always marked as a hot one, and here it is represented by this red color. And the hot zone is the one with the largest number of crimes committed at the point when nobody was patrolling the area. So that shall be a clue for a dispatcher, let's say, to dispatch more officers to patrol that area. So just take it as a requirement. Don't discuss how much sense there is in that. So let's take a look at the architecture right now, how it's going to be implemented. So our feature of interest will be handled by zone report service, which shall expose one public method called getZone to patrol. That for given date range, provided as arguments, shall return the ID of the zone that is the hottest, according to the logic I just mentioned. And this service has a couple of dependencies as a source of data. First is the schedule service. That provides list of schedules with the formal definition like that. And a single schedule entity represents the recurring event. I mean, for example, that officer John Smith shall patrol zone number 1 every Monday from 8 up to 10. In addition to that, we have exclusions supported. So for example, some PTOs or sick leaves or whatever. And here the definition is look like that. So we can query for the exclusions for given date range and return list of this kind of entities. So which officer and date range. Saying, for example, that John Smith is on PTO from the 1st up to 2nd July, whatever. And finally, we have list of crimes, and here the signature looks similar. So also query for the date range and returning list of crimes, saying that when the crime was committed and in which zone. So that's actually enough to implement that logic. So let's take a look at that logic right now. So here I have sample implementation of that class. My dependencies injected here, and one public method with the signature as mentioned on the slide. Of course, I'm not going to analyze the logic there. The only thing I would like to show is the length of that class, which is less than 200 lines of code. So the structure looks pretty well. So I have the class with the single public method doing exactly one thing, now with less than 200 lines of code. So Uncle Bob would be proud of that. So let's take a look at the tests for that class. And just have sample test. I'm preparing some input, some dates, some date range, some zones, some schedules, some crimes, and so on. And finally, I'm providing substitutions for my dependencies and creating the instance of the service, and finally executing my method and doing assertion. And that looks okay at the first glance. However, there's one major problem with this kind of test. If I were to cover all cases of my logic related to those schedules, exclusions, and crimes, I would need to create hundreds of such tests. And that would be extremely costly, not only in creation of that, but also in the further maintenance. So in this case, what I'm suggesting and usually doing is now to decompose that class and extract some subclasses, some auxiliary classes that will be responsible for subphases of the logic processing. Even if the class is not lengthy, even if it has exactly one public method, it's still often worth to be decomposed. And here I have alternative implementation of the same class. So as you can see, the same dependencies injected and the same public method, but most of the logic is now extracted somewhere else. For example, to officer timetable class, which now takes responsibility for schedule processing only. So responsibility for projecting schedules over particular points in time and applying those exclusions. So I have project method and exclude method as a public one, and I have tests for that. And right now, the number of inputs for the logic gets limited into to the amount that I was able to create a test using that semantic of test cases, providing various, different variations of inputs. And that make me able to provide pretty robust coverage over that logic. So within that technique, I was able now to cover my pretty, maybe not complicated, but also non-trivial arithmetics with robust test coverage. I can still, of course, have tests over my main class, exactly the same test because the interface is the same. But right now, this test works more like integration test, not the core logic test. Of course, this approach has also some drawbacks. To be honest, it's nothing more than a little bit more civilized way of extracting private methods from the class. We are no longer treating our service as a black box, but started to extract something from inside and put the test over that. But sometimes it is the only way to cover the logic in a robust way with the finite amount of time. So that was about coding style maybe and testing practices on the low level. Let's move to the next area I would like to cover. I mean, interactions between backend and frontend. So in our case, if we want to render our UI, I mean this list of schedules that we have on the bottom, we need to probably have some API. And in the clean approach, there shall be probably something like schedule controller that returns the list of schedules for particular date. And the DTO may look like that. So which officer at which zone and the date range. Fair enough. The list of zones might be reported by zone report controller. That would be, powered by zone report service, so the one that we just added. And it may return list of zones with the flag indicating if the zone is hot or not. However, here we are operating on IDs and UI usually needs to provide some display name. We should probably add some dependencies to the officer and zone controller. So the clean CRUD controllers that just returns list of officers and zones for ID to display name mappings. And that's pretty valid solution, of course, but a little bit complicated from UI perspective, as it actually needs to execute 4 queries and merge responses to render its content. And it means that it needs to have some merging logic and unit tests covering that logic. And that unit test probably shall cover not only sunny day scenarios, but also some error conditions, like response inconsistencies. So for example, we have some zone ID reported by schedule controller, but missing on a zone report controller or whatever. Of course, we may assume that it shall never happen because all our controllers have single database as source of truth, but everybody knows what happens if we assume that something never happens. So my idea here is usually that maybe we can try to help a little to our UI and maybe add display names to those DTOs. So if we extend those DTOs, we no longer need those 2 requests, and that simplifies a little bit logic. But I would go even further with that. Maybe we can aggregate our schedules and group them by the zones and extend those zone report DTO with the list of schedules for given zone. And in that way, we are getting the DTO that maps one-to-one to these boxes. And that means that UI needs to execute only 1 query and has no logic. Actually, no unit test requires. So what else can we achieve if we now extend this UI-friendly API concept? Of course, the most comfortable environment for doing that is that when a single team owns both backend and the front end of the single web application. Sometimes, of course, we need to expose our API to some external services. So we may consider actually creating 2 versions of our API, one, the clean, crude one, and the second, the UI-friendly one, that both of them using the same domain module as a source of data and has different controllers and DTO converters. What data can we put to this UI-friendly API, of course, in addition to regular entity stuff? So first idea was kind of resolve values, some preprocessed values exactly as provided in the previous example. But even more powerful idea is to add allowed operations flags. So let's imagine that in our application, we have the edit button over those schedules. But only officer commanders can modify schedules, and not for everybody, but for example, only for his subordinates. So it means that the UI needs to know that logic, to know if this edit button shall or shall not be displayed. But backend still also need to have this kind of rules just as a point of input validation. So it means that we are duplicating that permission logic, which is and we need, of course, to cover with unit tests on it on both sides, and also that creates some room for inconsistencies. So my idea here is that maybe we can put some additional flags to our DTO, like can edit, can modify, can delete, and whatever. So the UI does not need to evaluate the permissions, just gets the flag as there is. And the only place when this permission rules exist is still the backend. So both of those ideas has the one goal just to make the UI layer as thin as possible in terms of logic and put as much as we can to the backend. Why I push on this so hard? So as for me, usually creating the backend integration tests is much easier, and those tests are usually more stable than the UI web driver based tests. So I mean tests using some frameworks like Cypress, Nightwatch, or whatever. Creating the tests, UI tests of this class and maintaining them is usually pretty expensive stuff. And often it happens that the team just have this kind of test suite. The have is the most appropriate word there because those tests usually are flaky or not kept up to date. And our goal is not to just have a test suite, but to have a test suite that we can rely on. Keeping the test suite, which is not reliable, is now extremely ineffective from cost perspective because we just invested the time into creating that, but getting very little in return because we still need to do a lot of stuff manually because we are just not trusting the suite we have. So the idea of applying those techniques is that these techniques can help us to cover most of our features. Of course, not all of them, but at least most of them with tests without extending UI integration suite. And if we follow that, we have a chance to keep our UI integration suite compact enough that we can really afford maintaining them and keeping them in a good condition all the time. And in this way, getting our investment back. So the time we just invested into creating will come into return. So that was about the layer of backend to UI integration. Let's move to the next topic I would like to cover, which is architecture and technological stack. Actually, those slides are inspired by the product I was working a couple of years ago, which was a pretty successful one. And it was successful enough that the company decided to invest much more into that market and involved 5 times more people into that area. However, quickly it turns out that the pace of development was much slower than expected. And there was various problems for that, but one of them was a little bit too granular microservice architecture. Actually, that was the time when the microservices, was sometimes perceived as a remedy for all kind of problems. And everybody wanted to be as micro as possible. So sometimes it happened that we ended up with this kind of architecture. Of course, it's not the architecture of that application, but it depicts the same problem. So we have application with a couple of services like ingest, processor, transformers, analyzer, database wrappers, managers, and so on, spread among a couple different teams. And it may happen that most of the code that is being created there, and that means also most of the engineering time is not devoted to the business logic, but to the maintenance of those interactions with their DTO structures, error handling, connection management, retries, configuration, authentication, and so on. And whenever any feature request comes, it requires changes in a couple of services, sometimes spread among 2 or more teams, which involves never-ending discussions between engineers. Who shall do what, which API to change, and how? Sometimes those discussions get really hot. Sometimes it needs involvement of managers even and scheduling more meetings to discuss the problems. The impact or our efficiency in deliverables is pretty straightforward there. I do not mean that the microservices architecture is bad in general, but just asking that we shall be a little bit more reasonable with creating a new service and always ask the question if the new service is going to really cover independent portion of logic. And for me, the services are independent. If most of feature requests, of course, not all of them, but most of them, requires changes in the single backend service and the UI. If most of our features require changes in the same two services, maybe they shall be a single one. Note that maintaining the interaction between two domain models within single service is usually 2 orders of magnitude cheaper than maintaining the API and the contract between two services. So my point here is that whenever we are choosing our architecture or technological stack, let's always ask the question about what we really need to be efficient and try not to bias to the technologies that are now being really fancy at that point of time. And there is a lot of talks about it, the hype around that. Just select things that are really best tailored for the application you are creating. And the last area I would like to cover is the defect management. Whenever I hear that term, the first thing that comes to my mind are those presentations when somebody is proving that the quality of the product got improved because there were no 8 customer-facing defects in the previous quarter, and right now there are only 6. I'm not talking about anything like that. So what is more important for me usually is no defect avoidance. Actually, most nasty defect avoidance. Whenever the code is being written, the question is not if we are going to introduce defects, but how many and what kind of them. And as long as although all defects are not welcomed, but some of them are more nasty than others. So if you can identify the changes in the code that may result in introducing this kind of defect, we may enforce some more strict and restrictive quality procedures, like more profound code review, require more test layers, or so on. Of course, that would be ideal to have some such rules for every kind of change. But as our resources are limited, maybe we shall not find the places when it is especially justified. But what kind of defects are especially nasty? So my list here starts from defects that may result in data loss. I think everybody would agree that there are few worse things in software than losing customer data. Because if we are losing customer data, it means that we are usually lose customers as well. So no further discussion is needed there. The number 2 on that list are defects that may result in data inconsistency. I mean, all kinds of bugs that may result in some structure in our database that is not intended. And the impact on the customer might be different, sometimes very high, sometimes very little. But still, it is number 2 on that list for me. Why? Because fixing this kind of defects usually means we need to create a migration code. We need to test that migration code and finally execute that on all environments we have and finally on the production. A lot of time needed for that. Number 3 on that list are defects that are intermittent. So sometimes it happens that we are changing logic which is executed very seldom or only under some special set of conditions. And then we can introduce the bug that will be realized only after a couple of weeks or months as a single time occurrence. Then second time occurrence, and we need to spend hours or even days to finding the root cause. Again, a lot of time required. You may wonder why I'm so concentrated, or the amount of time that is needed to fix the defect, not, for example, on how particular defect is annoying to the customer. Note that I'm talking about defect avoiding, not fixing them. And my point is that if defect is going to be annoying, it's also going to be visible. If it's visible, it's pretty rare chance that somebody would realize the defect before the code is gets promoted. These classes of defects that are mentioned on the list are, again, really likely not to be spotted by anybody. And later on, you would require a lot of time within the sprint to fix that. And if we spend the time within the sprint for creating, for example, migration code, it means that we need to sacrifice something, either our feature tasks or our code maintenance tasks, like extending test suite or whatever. And in the first case, we may not deliver now this visible progress after the end of the sprint. And the second case, we're just introducing technical debt directly. In both of cases, we are falling back into that vicious circle of frustration, poor quality, and no delayed deliverables. And avoiding that kind of state is my definition for being fully customer oriented. And that moves us slowly to the summary of that talk. So my main goal was to show that the running a software business and actually being the software developer is about the skill to align together our relations with business, the architecture, the coding style, the testing practices, together with the customer needs and expectations. Now, only if we are able to find the right proportions and right matching between those two things, we have a chance to create really successful product. I've shown a couple of techniques that may, reduce the cost of our work, cost of our development, sometimes at the expense of perfect and clean application or code structure. But for me, this code structure, the cleanness of that, is worth only as much as it helps us with the smooth development. So if we are able to reduce the cost of our development, we may invest that time somewhere else. For example, for increasing the feature set of our application, or to increase the quality, or finally, we can just reduce the price of our product. In all of that cases, we are tuning the competitiveness of our product. Of course, those techniques might or might not be applicable into the products we are working on. However, I just wanted to show that this general way of thinking, which is always focused on our business and the product we are selling, not only on our code. So my final point is that whatever principles we are defining for our teams, whatever practices we are enforcing, let's always ask ourselves those two questions. First of all, if it is something that we can really afford maintaining for the longer period of time. Otherwise, we'll just invest some time at the beginning and later on get very little in return. And finally, and probably most important, if this practice will really help us, our product to achieve commercial success. So that's all from my side. Thank you very much for your attention, and I'm giving my voice back to the stage.